h prime of x would equal to f prime of g of x times g prime of x. So to sum it up in real people terms, what it's saying is we would take the derivative of the outer portion and multiply it by the derivative of the inner portion. So now this is going to open the door for us to be able to take a lot more derivatives. So let's start off with saying we've got that f of x is equal to x squared minus 3x plus 2 to the third power. Now, up till now, if we were going to take this derivative, we would have to raise this trinomial to the third power, which, again, I don't have a life, but I've got better things to do than that. So, what we do is we do the chain rule. Now, the chain rule here involves the outer portion, and the outer portion is just a power rule situation. So this becomes 3 times x squared minus 3x plus 2 to the second power, which is what you would probably expect it to be. And then times the derivative of the inside part. What is the derivative of my g of x portion here? 2x minus 3. Now, if you want to clean that up, you can. You could distribute and say, you can't distribute into here, but you could distribute the 3 with the 2x minus 3 and get 6x minus 9 if you wanted to do that.
I thought you wouldn't distribute the 3 if it wasn't, you would only distribute the 3 for the first part. Why you didn't?
No, you can distribute it onto any part because multiplication order doesn't matter. So I can, or grouping doesn't matter either. So I can group the 3 with this, or I can group the 3 here. But I can't multiply it in here because, again, I have to do exponents before I do my grouping. And I don't want to square that either. I didn't want to cube it. I don't want to square it either. All right. Another situation, f of x equals to the square root of 3x minus 5. Well, we're once again at a square root situation. And remember, if we had just the square root of x, then our derivative was 1 over 2 times the square root of x, because it was, remember, this was x to the 1/2, so the 1/2 came here, and then you ended up with an x to the negative 1/2, which pulled that square root to the denominator. We've done that a few times, so I didn't want to go through the full thing with it again. It doesn't change. But a similar thing's going to happen here. We're going to start off with this outer portion being 1 over 2 times the square root of 3x minus 5. But then we get to taking the derivative of the inner portion. So what is the derivative of the 3x minus 5 part?
3.
Just 3. So the derivative here, I could write as 3 over 2 square roots of 3x minus 5.
What? So, on the first problem.
Yes.
So we do the derivative of the first one, like, the first equation at the top to get the 3 times that.
Mm-hmm.
And then we take the stuff only on the inside
Mm-hmm.
and do, okay,
Perfect.
let me write.
And remember, again, I'm treating this as if it's 3x minus 5 to the 1/2 power.
Question,
Yes.
on that one,
Yes.
why do we make it 3/2, square root of 3x minus 5? If we take the derivative of under the radical.
The derivative under the radical is 3, right? So I multiply it by 3. Well, if I'm multiplying by 3, remember 3 is the same thing as 3 over 1. So it's just 3 times 1, and then nothing changes in the denominator. Does that make sense? You sure? Okay. You didn't look very convincing when you nodded there.
I think I'm just overthinking it.
You may. It takes some practice. All right, can I erase this? Well, it's still chain rule. All right, so we got f of x equals the sine of 5x squared. So, remember, the derivative of sine of an angle is the cosine of the angle. Now, up till now, that angle's been x. But here we're using 5x squared as our angle, so it's the cosine of that angle. So that's the derivative of the outer portion. And then the derivative of that inner portion is what is the derivative of the angle itself? What is the derivative of 5x squared?
10x.
10x. So it's the cosine of 5x squared times 10x. A lot of times in cosine problems, you'll see the other value in front. Does not matter. Are we good here? Okay. Okay, well, let me erase the whole board here. And I'm gonna stop this video.